Ana Luísa Garcia Massager, Millás, que é a nossa invited speaker, e vai apresentar o trabalho 3DBS, 3D Biotechnology Solutions Startup, Its Challenges and Projects. Obrigada, Ana Luísa, por ter aceito o convite e boa apresentação. Você quer que eu te avise quando estiver faltando 2 minutos, 3 minutos? Você está mudo, você está com o microfone mudo. No canto esquerdo embaixo. Deixa eu ver se eu consigo. Eu vou dar um ask to unmute para ver se você aparece aí.
Ai, agora sim.
Imagina. Normal.
Tá? Você sabe? Tinha colocado o fone, mas o fone ficou ruim. Bom dia.
Sem problema. Você quer que eu te avise quando estiver faltando 3 minutos para finalizar?
Pode ser. Eu vou compartilhar aqui já. Só me confirma se você está vendo a tela.
Estamos vendo sim, Ana Luísa.
Ah, legal.
Falta só colocar no modo apresentação. Isso. Pode começar.
Okay, good morning, everyone. Thank you to be here. I would like to thanks especially Professor Newton and Professor Monica for the invitation. Congrats all the organizers of this Congress and conference. Since I started my master's degree in 2010, I've been participating on the MRS Congress, and it's great. Today we're going to talk a little bit about my startup, that is 3D Biotechnology Solutions, a bit about our challenge and projects here. We are in the Brazilian market since 2017, so it's great to talk about our story a little bit. My name is Ana Millás. I'm going to present myself a little bit soon. So just to clear what we've been doing in these 4 years, the last 4 years, I'm gonna show you briefly a video from 3DBS. Let's see.
Biofabrication is an area in rapid development that has attracted worldwide attention. A transdisciplinary field inspired by nature structures that reconstructs complex tissues and organs. Built upon engineering techniques, it uses cells, polymers, nanoparticles, biomaterials, and biomolecules. These technologies have been encouraged by the development of 3D printing techniques.
A tecnologia de bioimpressão 3D atua como uma plataforma que possibilita diversas aplicações nos campos da medicina regenerativa e, mais atualmente, da medicina personalizada. Somos capazes, com essa tecnologia, de reconstruir tecidos biomiméticos e modelos in vitro que poderão predizer condições específicas e simular doenças.
Bioprinting should have a strong impact in health and in other areas, such as the cosmetic and food industries. Several research groups have been focusing their efforts in this exciting field.
3DBS é uma startup brasileira fundada em 2017 que desenvolve equipamentos para o campo da biofabricação, bioimpressoras e equipamentos de eletrofiação. E a gente conta com o apoio da FAPESP através do seu programa de inovação em pequena empresa, que nos permitiu desenvolver nosso primeiro protótipo. Atualmente, a gente já forneceu equipamentos para institutos de pesquisa e universidades, como Unicamp, Unifesp, Federal de São Carlos, entre outras.
The 3DBS biofabrication equipment are proprietary and allow for customization such as hybrid systems, heating, cooling, photopolymerization, extrusions of polymers and pellets, air filtering systems, and a number of extruders. 3DBS operates on an educational to complex multi-user layout models to take on different research demands and challenges. It also operates in the training, consulting, and development of bioprinted applications of in vitro tissues and models. Recently inaugurated, its biofabrication lab has an infrastructure dedicated to the development of human tissues and organs, focused on high-impact projects and the offering of bioprinting services. Open to researchers and enthusiasts. If you have a project in the bioprinting area or seek a partner that can make your projects feasible, get in touch. It'll be our pleasure to welcome you.
Okay. Oh my God.
Fabrication.
No. Just a second. Let's see what's happened here. Okay. So let's start our presentation. So we are in Brazil since 2017. And I would like to say something. Once I heard from a friend that if we have every day one idea, at the end of the journey, we're gonna have a great idea. And I think during a conference like the MRS that we are having now, maybe in the finishing the conference, we must have 10 great ideas. I hope you enjoy the lecture. So we are in 3 partners initially. Pedro Massagueri is the innovation strategist. He's a business administrator with PhD in science and technology policy at Unicamp, with MBA in GV in strategic business. Hamilton Orient is my another partner. He's a senior design and project. He is in the making all the pieces of our equipments and machines, electron spinning and bioprinters. And he has an experience for more than 30 years inside the industry, working with CNC machines, much, much more complex than what we're gonna talk today, that's the bioprinters and electron spinning. I am the crazy scientist of 3DBS. I made my master's degree in chemical. I'm a biologist and made my master's degree in chemical engineering and my postdoc in pharmaceutical. So a little bit about my career that I think is really important for everybody that's here participating. We work in a really interdisciplinary and transdisciplinary area. So I'm a biologist as my first formation and made social science together at Unicamp in 2000. So after that, I moved to Amazon to work there in a great and beautiful place that's Mari.marsalla, to work with the traditional people there. So there I met the therapeutic and natural oils that today we use in our research inside the company. So after Amazon, I moved to São Paulo to work in the industry, textile industry. And then I missed the academic field. So I came back to academic field to make my master's and my PhD, but not more in the biology. I made my master's degree and PhD at the chemical engineering school at Unicamp. And there I started to work with these technologies as 3D printer and especially with electron spinning. The electron spinning technology that we're going to talk a little bit today came from the textile industry. And because of the novel ability, this technology nowadays is used for the tissue engineering and the regenerative medicine field. During my PhD, I made part in the electron spinning company in Nottingham Training University in 2012, United Kingdom. And afterwards, during my PhD as well, I made part of my researcher at Cornell University in USA. Afterwards, during my PhD, I met a Milton that's a partner since my PhD, and then he built our first bioprinter that we call today here in Brazil is Latão, our first bioprinter. But was amazing to work with bioprinting in 2014. So in 2016, me and Pedro, that is another partner, and also my husband, we start to think in open to take all this knowledge, all this research that I was being doing in the last 10 years and put in the market. And that's why the FAPESP Foundation is too important for us, because was the support for our initiative to open 3DBS in 2017 with PIPI. That's a program for small companies. It's supporting several companies and startups, innovation startups in Brazil. So we work in this big and huge interdisciplinary field here in 3DBS. The concept of biofabrication is the biofabrication can be defined as the production of complex living and no-living tissues, biological products from raw materials such as living cells, molecules, matrix, polymers, and biomaterials. So you combine all these components to make a complex, to rebuild, to reconstruct complex tissues. But from where came from this big area that come from engineering, from biologic, from pharmaceutical, from medicine, from chemical, come from the observation, come from the nature inspiration, the biomimetics. Everything that we do inside the biofabrication come from the nature. So more important than have knowledge and the expertise to do a lot of technical things, is important to know how to observe, how to see, how to understand what's happened in the nature, to mimetize what we have there. As we know, our body is made of a lot of tissues, and those tissues, all of them are three-dimensional, not two-dimensional. Traditionally, we make these tissues inside a petri dishes, and these petri dishes we put together cells, human cells or animal cells, to grow side by side in bidimensional constructs. But now with these technologies, as electron spinning and bioprinting or 3D printing, we can make three-dimensional tissues. And this is the biggest challenge. How we can be close to what is really are our tissues, native tissues. So we are close to make a complex organ or complex tissues using 3D bioprinting. Do we have organs in the market? Because we have a big demand, this is the promise, this is the biggest promise of bioprinting, that we have a big problem, a big demand of thousands and millions people waiting for organs, a transplant for organs, and we think that one day we could give these organs, printing organs inside the hospitals. But we are a little bit far away from that. Maybe in 10 years or 20 years, we gonna have this, and this is a great opportunity. But now the bioprint is facing the bench, the experimentation. So we can do with bioprinters, as we're gonna see, small tissues with some types of cells combining each other and making it more organoids or organ or tissues. And we can put this in the market, as we're gonna see, but not complex organs yet. So the 3DBS solution is, we work in the regenerative medicine field, huge field, working in tissue engineering. I am a tissue engineering scientist. We have now the team growing day by day, year by year, and we work with two technologies, the bioprinting and electron spinning technologies, to attend researchers making equipments first. We developed these equipments inside our place, and we put the first bioprinters in the Brazilian market in 2007. And now we just launched in this year our first bioprinted tissue using our technologies. So as I said, we work with bioprinters and electron spinning equipments that we customize in a construct. We are in the market today. We work in bioprinting and electron spinning tissue engineering services as a consultant and prototyping. And now we are developing applications, always with partnerships, with another collaborations, universities and another industry. And our market segment is mainly research institutes, universities, hospitals, pharmaceutical and cosmetic and veterinary industry, and educational field general. But we are not alone here. We have competitors, but the field and the opportunities are immense, that they are huge. So it's good to know that in 2017, when we started, we had just about 40 companies, all worldwide. Nowadays, after 4 years, we have more than 100 working in this field of biofabrication with different applications. In Brazil, we were the first one in 2017, and now we have in Brazil more than 7 startups and companies working in the biofabrication field. This is really good to know. And Organovo, that you see here, is in San Diego, USA, was the first one in this bioprinting area field. And they are from 2007. So we are from 2017, 10 years after. What is great to be here in Brazil? We noticed in 2007 that there were a lot of people trying to find the machines, the 3D bioprinters, but they were so expensive because you had to import these machines here. So when we put it here, this first machine in Brazil, this technology just spread in all the states of Brazil. And now we have more than 70 groups working with this technology here. So we wrote this, we published this article in 2019. So this data maybe is growing day by day, year by year. It was 2 years ago. And we found 60 groups working in these two areas, bioprinting and tissue engineering. And it's good to know that these groups are completely interdisciplinary. They are from different areas. So you mix engineering with a big group here with the health science. They are the biggest one. So we have to work together. We have to talk with each other to make something, to develop some these complex tissues. This is our more complex bioprinter we have 3 print heads here, maximum 4 print heads with UV lights, with cooling system, with aseptic environment, different. You can work with different biomaterials, with heat in the head, also in the bed. You can customize whatever you need. So there you can see our 3 main layouts. This is a more small one, desktop one, to educational for you that is just starting work in this field. You don't have a lot of money to spend in the biggest one. So this is the starter. We have the what we call here carro-chefe, that is the Genesis one. This machine, this bioprinter has 2 print heads, and we have the octopus one, the more big one. So you can customize whatever you want. So we have also the electron spinning machines. This one was customized to Embrapa, Dr. Luciano Paulino in Brasilia, and they want to have 6 different structures to work with different biomaterials together to make them nano and microfibers like this. You can see the SEM microscopy, these images. You can make different fibers to work in different applications using combining materials, nanomaterials, biomolecules, and everything else. Just a video here, the system working. And we have more simple ones also. This is the type of material from the electron spinning. They are fiber matrix, nano and micro matrix. And we are with a project to a bone regeneration together with Mandiki. Is the place, the school that we are incubated nowadays in Campinas, to make applications for the odontologic regeneration. And this work I started in 2010 in my master's degree is artificial skin using both technologies, bioprinting and electron spinning. And in this case, we combined the therapeutic oils that I met in 2004 when I went to Amazon, Scopaíba oil, Andiroba oil, and other oils. We have a patent at Unicamp, Innova Unicamp, with this technology. We incorporated these oils and we put it in animals, or in the future humans. We don't have the clinical assays, just the preclinical assays in rats, and make the wound regeneration for chronic wounds. We have also a project coming, funding, supported by FAPESP, to make vascular grafts. We know that it's a challenge because we have to have the nutrition of these 3D models, these 3D objects, because they are alive and they need this nutrition of blood vessels as we have in our body. So we build a 4th rotational place when you can make combining technology of electron spinning and bioprint to make these vascular grafts. You had a great opportunity to see this presentation with Karen Galvão. That's an internship in our startup, and was, I think, on Wednesday in this conference. Check there afterwards. Was our project presentation. Great. So what we make is using both technologies to reconstruct, to mimetize one blood vessel. See the system functional. And this is just a little of this. Is a hybrid system combining fibers with biowinks, with cells, muscle cells, and fibroblasts, and endothelial cells. So we can combine both technologies to make these structures. And now we know that we can simulate organs in a dish. So it's more organs. And we just launched this year a bioprinted skin model as alternatives for these animals. The animals that we call cobaias here in Brazil. Since 2019, we cannot use in cosmetic industry animals anymore. So we have to have these alternatives that mimetize our skin organ. So we just launched our first bioprinted application tissue to attend researchers inside the universities, cosmetic industry, and the pharmaceutical industry to test new ingredients, new products, drugs, and what else? Why?
3 minutes. 3 minutes.
3 minutes, okay. The advantage to use this is because we have scalability and reproducibility when you compare with manual methods. So this is the histological cut that we have here, the bioprinted skin, the 3DBS skin. You see here the dermis and here all the stratification of the epidermis. What we aim is to make a skin with vascularization to put in the patients to treat chronic wounds also. Some of our clients, I brought some pictures here all around the Brazil territory. We have our laboratory now, financed, supported by FAPESP, is a small clean room and also a biofabrication laboratory. So lab, you can come, please visit us. We can talk about a collaboration or about a project together. Our contacts, they are here. Go to the website of 3DBS. It's just a new one with everything that we are doing. Some of our our customers and partners, and our team that is growing day by day. Thank you, team, and thank you very much.
Thank you, Camila, for a very nice presentation. Obrigada, Camila, Ana Luísa. Estou ficando maluca já, viu, gente? Fim de evento. Ana Luísa, inclusive, foi entrevistada nas startups da SBP Mate, não foi isso, Ana Luísa?
Foi, isso mesmo.
Foi linda a entrevista, muito bacana.
Ai, é melhor falar em português, né? 1000 vezes melhor.
E assim o pessoal pode participar melhor também, né? Dá mais chance para a turma perguntar. Gente, nós temos tempo para 1 ou 2 perguntas. Alguém quer perguntar alguma coisa para a Ana Luísa?
Oi, Ieda.
Fala, Newton.
Tudo bem? Bom, primeiro, Ana, parabéns pelo seu trabalho, parabéns pela sua empresa. Eu tenho uma curiosidade que eu fiquei com vontade de perguntar lá na entrevista da SBP Mate, acabei não perguntando.
Que bom, Newton.
Tudo jóia.
Obrigada.
Eu tenho uma curiosidade a respeito de o quão difícil, eu sei que a resposta vai ser muito, mas eu queria ter o seu feedback, liderar uma equipe multidisciplinar em uma empresa. Você pode dar uma palavrinha para a gente sobre isso?
Com certeza, Newton. Eu acho que primeiro, para liderar uma equipe dessa, a gente tem que ter uma paixão, que eu quis trazer um pouquinho aí na apresentação, né? Uma paixão que vem lá do início, daquela maluca que faz biologia junto com ciências sociais, e daí todo mundo já fala, biologia com ciências sociais, você vai fazer isso.
A pessoa não é muito normal, né, fazer biologia com ciências sociais, mas tudo bem, continua.
E daí você vai morar na Amazônia com uma oportunidade que surgiu justamente demandando alguém que tivesse antropologia, que é das ciências sociais, junto com a biologia. Aí as pessoas começam a falar, até que ela não é tão maluca. E aí saí, fazia a engenharia. Então, eu acho que eu fui, durante a carreira, aprendendo essas diferentes linguagens, né? A linguagem do engenheiro, a linguagem, e que, na verdade, na engenharia de tecidos é uma nova linguagem que se cria. E eu acho que é essa capacidade de poder dialogar, né? De trocar, e principalmente de ter a humildade de em diversos momentos de falar, eu não sei isso. E isso eu lido direto com os bolsistas que a gente tem na FAPESP e tudo lá, que são bolsas TT, que são espetaculares. Eu acho que é uma grande oportunidade para quem tem essa chance de ter uma bolsa TT dentro de uma startup, é um aprendizado, assim, de um mundo. E é isso, às vezes eles falarem, não, mas isso aqui, desse teste, que não sei o que, mas por que aquilo? Porque os bolsistas são muito, parece criança que pergunta tudo por quê, por quê, por quê. E de ter essa humildade. Fazer a gestão é também falar, eu não sei, eu trabalho numa área muito ampla, então eu sei um pouquinho de tudo, nada tão profundamente, às vezes, né? É esse o grande
Perfeito.
desafio.
Obrigadão.
Bom, gente, então, com isso, nós já estamos no limite do nosso tempo. Agradeço a Ana Luísa pela apresentação, excelente, é sempre muito bom te ouvir falando, viu, Ana Luísa? É uma inspiração, com certeza, para as mulheres também, né, que querem empreender. Se a área científica já é difícil, a área de empreendedora, então, é quase um vácuo para as mulheres. Então, parabéns pelo trabalho, pela empresa, pelo caminhar, pela apresentação.